Alright, so today we're going to talk about trigonometry and area. Figure out what I did with my notebook. Okay, so this is going to be similar to what we did last week. So remember last week we talked about how to find the area of regular polygons. And we took this polygon and we said, okay, if you draw every radius from the center out to a vertex, you're going to create this number of triangles. And if we create this number of triangles, then I can take 360 divided by that number of triangles to find this angle measure. And then we're going to divide that triangle in half because I have to have a right angle for those special right triangle ratios. The 30, 60, 90, 45, 45, 90. Sorry, ringing a bell. Okay. And then using that stuff, we can find the apothem, okay, or we could find half of the side length to find the full side length, because in order to find the area of a regular polygon, you take 1/2 the apothem times the perimeter, which remember the apothem is from the center directly out to one of the sides. Now, that worked with the special right triangles last time because we had maybe like 6 sides. We had a hexagon. So when you take 360 divided by 6, the big angle in the big triangle, or the top angle in the big triangles was 60. Divide that in half, you get 30. So you'd have a 30, 60, 90 triangle. Okay? Or there were some other ones where like if you had a quadrilateral or a square and you had 360 divided by 4, that would give you 90. Divide the 90-degree angle in half, you get the 45, 45, 90 triangle. Okay? Now that only worked for certain regular polygons because those relationships only work for 30, 60, 90 triangle or 45, 45, 90 triangle. What we're going to talk about today are all of the other regular polygons. So, a polygon that has 9 sides, a nonagon. Now, in order to do this, I actually think this is maybe a little bit easier because sometimes those special right triangles, those ratios can be kind of challenging with the s squared to 2. We are going to use trigonometry. So remember SOHCAHTOA? Okay, so we have sine, opposite over hypotenuse, cosine, adjacent over hypotenuse, and then tangent, opposite over hypotenuse. So we're doing almost the same thing we did last week. But when we're looking for the missing side, usually it's going to be the missing apothem. We're going to have to use one of our trig ratios to find the missing side length, okay? So, let's do this down here. I do have a little typo here. It should be with 10 centimeter sides, not like 1 centimeter sides. Okay, so we want to find the area of a regular nonagon with 10 centimeter sides. So, a nonagon, 9 sides. So, if you were to go through here and draw all of the radii, how many big triangles would we get? 9, because it's a nonagon, right? You would draw 9 radii to separate it into 9 triangles. So what I want to do, and we're going to do this a lot today, go ahead and just draw one of those 9 triangles. Just one of those, okay? So this is one of the 9. So the central angle here, right? So this whole bottom is 10. This central angle, to find that central angle, just like we did last week, I would take 360. I split that 360 into 9 triangles. So when I take 360 divided by 9, we would get 40. Now here's the thing. Whether you're doing those ratios where you do s squared to 2, s, 2s, s squared to 3, or trig ratios, you have to have right triangles. The Pythagorean theorem, all of those ways that we know how to find missing sides only work for right triangles. Also, I need the apothem, right? Which would be this right here. So what we did is we took the big triangle, we split it in half. This side here is the apothem, okay? But what it also did is it split that angle in half. So it was a 40-degree angle. It's now a 20-degree angle. It also splits that side in half. It was 10 when I split it in half. Just that half is going to be 5. Now what we did before is we had a 30, 60, 90 triangle. This is not a 30, 60, 90 triangle. So what we're going to need to do instead is we're going to need to use these trig ratios. So what I need to know, what I'm looking for, is that side right there. Okay? The this triangle, as a reminder how these trig ratios work, you take sine, cosine, tangent of an angle. So I first need to decide if I'm going to take sine, cosine, or tangent of 20. How I'm going to know is I'm looking at the two sides I either have or I'm looking for. I have the bottom, which in relation to the 20-degree angle, what side is that? And between the opposite, adjacent, hypotenuse. What side is that? From the 20? Opposite. Opposite, okay. Right, remember doing this? Okay, so if I look at this triangle, the side opposite is the 5. I'm looking for this one. So once again, in relation to the 20, that would be the adjacent. Okay, those are the two sides I have. I have adjacent and opposite. Adjacent and opposite. So A and O. Which of these has the A and the O? The tangent. Tangent. So to set up this ratio, we are going to take tangent. You always take sine, cosine, tangent of an angle. So we are going to take tangent of 20. And tangent is opposite over adjacent. So we are going to take 5 over A. 5 over A. And then we're going to solve for it. Remember whenever we did this last chapter in chapter 8? If you have the variable in the denominator, you can't do anything until you get the variable out of the denominator. So we need to multiply both sides by A. So we have A tangent of 20 equals 5. And this is A times the tangent of 20. So to get rid of the tangent of 20, we would divide both sides by the tangent of 20. So to solve for A, the adjacent side, the apothem, you would just take 5 divided by tangent of 20. You could just plug that in your calculator, and you should get about 13.7. So the apothem is going to be 13.7. To find the area, you need the apothem, which I just found, but we also need the perimeter. So to find the perimeter, this is a regular nonagon. One side is 10, and how many sides are there? 9. So 9 times 10, a perimeter would be 90. So once you have these things, you're ready to plug it into your formula. To find the area, you're going to take 1/2 of the apothem, which we found was about 13.7, times the perimeter, which is 90. And if we round, we should get about 618 centimeters squared. So it's almost the same thing we did last week, but instead of using this special right triangle relationships, we're using the trig ratios. Okay, now the other thing we're going to do today is much easier because it's just using a formula and plugging it in. So we already know how to find the area of a triangle. The area of a triangle is 1/2 the base times the height. But the problem comes in that if I don't know the height. So if you were to look at this triangle down here, to find the area of this triangle, I'd take 1/2 the base, which I know the base, but I'd have to know the height. I don't know the height. Or if you were going to use the 12 as the base, you'd have to know the height. You don't know the height. Okay, so that's where the problem comes in. So there's this formula. It's just an application of what we just did. If we wanted to go through the proof, we totally could, but for time's sake, we're not going to go through the proof. It turns out that to find the area of any triangle, okay, you're going to take half the product of the length of two sides. So you're going to pick two sides, okay? You are going to multiply those together times 1/2, and you're going to multiply that by the sine of the included angle. Sounds pretty confusing, okay? Here's what this means. Let's say you knew they gave you the measure of angle A. You're going to decide what sides to use depending on what angle you have, because it has to be the included angle. So angle A is included between that side and that side. So to find the area of this triangle, you're going to take 1/2. Those are the two sides you're multiplying together. You're going to take B times C. Then you're going to multiply that by the sine of A. If by chance, let's say they gave you the measure of angle B, okay, you would take 1/2 C times A times the sine of B. Okay? Or if they had given you the measure of angle C, you would take 1/2, multiply those two sides together times the sine of C. So you're taking the sine of the angle and then the two sides that kind of create the angle. So to show you that down here, most of the time they give you the sides and the angle that you need, but just kind of keep that in mind. So to find the area of this triangle, you're just plugging numbers into the formula. You're going to take 1/2, okay? You're going to multiply the two sides together. So we're going to take 21 times 12. 1/2 of 21 times 12 times the sine of, and you need the angle that is included between those two sides, which they give me is 48. And then this is just plugging it into your calculator. If you multiply those together, you should get about 94 centimeters squared. Okay, let's get this glued into page 39. This is section 10.4, and it is trig and area. Okay, so first ones. We're going to do 3 of these for your homework. You just have 4 of them. These are the ones that are a little more challenging because the other ones are just plugging them into a formula. So this one says, find the area of each regular polygon. We're going to round to the nearest 10. So, number 1, we want to find the area of a decagon. A decagon with side length 4 yards. We want to find the area of a decagon with side lengths 4 yards. Now, if you want to draw a decagon, knock yourself out. Go for it, okay? But what we're going to do with that decagon is we are going to break it apart into how many triangles? 10, because it's a decagon, 10 sides. So what I like to do is I just like to draw, one of the 10 triangles. Now, what I know whenever I take this decagon and I split it into these 10 triangles, to find this angle here, that's that center angle. So I would take 360 divided by the 10 triangles. That big angle there is going to be 36. Now these trig ratios, these special right triangle ratios, the Pythagorean theorem, they only work for right triangles. So I need to cut that in half. So I'm not looking at a 36-degree angle. I'm looking at an 18-degree angle. Now, in order to use the trig ratios, you need an angle measure, but you also have to have a side length. And they tell me that. They say the side length is 4. Now, be careful here because this whole side is 4. But what I did is I cut that in half. So this side right here is not 4. It's 2. That's the triangle we're working with. And remember, this right here is your right angle. What I need in order to find the area of a polygon, I need the perimeter, which I'll be able to find, but I need the apothem. The apothem is going to be the one that goes from the center straight out to the side. It's going to be that side that has the right angle. This is the apothem that I'm looking for. So next we need to decide which of these trig ratios I'm going to use. So you're always, when you're deciding which trig ratio to use, you're going to look in relation to the angle. So this angle that I have right here, the two sides that I have, this 2 is which side? Opposite, because it's opposite of the angle. And then the apothem that I'm looking for, adjacent. Remember, this side is the hypotenuse. Okay? So what I have is I have opposite and adjacent. Which trig ratio is opposite and adjacent? Tangent. Tangent. So we are going to take tangent of the angle, which is 18, equals opposite, which is 2, over adjacent, which I don't know. Now, just like the last example we did, if your variable's in the denominator, you need to get it out of the denominator, so multiply both sides by a. So we have a times the tangent of 18 equals 2. To get rid of the times tangent of 18, we would divide by the tangent of 18. And in your calculators, you can just take 2 divided by tangent of 18. Now, for these ones, what I would suggest, I know it says round to the nearest 10, but to get the most accurate answer, until you get to your final answer, I might suggest you keep maybe 3 decimals. So if you keep 3 decimals, it'd be about 6.155, which is your apothem. Now to find the area, you need 2 things. You need the apothem, but I also need the perimeter. It tells me that one of the side lengths is 4, but how many sides do I have? 10. So to find the perimeter, we do 4 times 10, which is 40. Once you have these 2 things, you're plugging them into your formula. So to find the area, you're going to take 1/2 the apothem, which we found was 6.155, times the perimeter, which is 40. You should get about 123.1 yards squared. So similar to that first one we did. Questions on that one? Okay, let's try one that's a little different than that one. So number 2, I want to find the area of a 20gon with radius 2 millimeters. We're given the radius this time. Now, the idea is still the same. We're going to take this 20-sided figure. If you want to draw a 20-sided figure, go for it. I'm for sure not going to do that because I know I'm going to take this 20-sided figure and I'm going to break it apart into 20 separate triangles. So when I take this 360-degree central angle and divide it by 20, when you take 360 divided by 20, that angle right there is going to be 18. Remember, we're not going to deal with that triangle, okay? We are going to cut that triangle in half because I have to have a right triangle. So that top angle is going to be 9. Okay, now, this time I'm given the radius. The radius. So if it helps, you might go back to one of these pictures and look at what the radius looks like. Whenever you draw one of these triangles, right, the big triangle, those 2 lines that I drew in purple, those are the radii, okay? We're looking for the apothem, but if you look at both of these triangles that I've created, the radius is which side in each of these triangles? The outside, yes. It's the what? It's the hypotenuse. See that? And every single time, it's going to be the hypotenuse. So this side right here, that's your 2. Okay, that's what you're looking for. Now I know that in order to find the area, I need the apothem. I need that side right there. Now this time, if I look in relation to the 9-degree angle, the apothem's the adjacent. I don't have the opposite this time. We have the hypotenuse. I have adjacent and hypotenuse, which is which of these ratios? Which has AH. Cosine. So to, right? So this time we're going to take cosine of 9 equals adjacent, which is A, over hypotenuse, which is 2. Now this one's nice because the variable's in the numerator. So to solve for A, we are just going to multiply both sides by 2. So in your calculator, you just take 2 times cosine of 9, and we should end up with the adjacent side, which is the apothem, should be about 1.975. Now here's the thing. In order to find the area, I need the apothem, which I just found, but I also need the perimeter, which means I need the side length. And they gave me the radius. They didn't give me the side length. What else do I need to find? Am I going to need this right here? This bottom right here? I need that opposite, right? So now, to find the opposite, I now have opposite and hypotenuse. Which ratio has opposite and hypotenuse? Sine. So this time we are going to take sine of 9 equals opposite over hypotenuse, which is 2. And you're going to do the similar thing. You're going to multiply both sides by 2. And when you take 2 times sine of 9, you should get about 0.313. Okay, but you have to be really, really careful here, because that's not my side length, not the entire side anyway. That's just half of it, right? I need that entire side length, so you'd have to multiply that by 2, which would give you 0.626, which even that isn't really what I need. I need my perimeter. What am I going to do with the 0.626? Yeah, there's 20 of those sides, so my perimeter is going to be 12.52. Okay, so to find the area, I need the apothem and I need the perimeter. We're going to plug them in. So the area is 1/2 times the apothem, 1.975, times the perimeter, 12.52. And for these ones, we can round to the nearest tenth. You should get about 12.4 millimeters squared. Okay, let's do one more of these. Okay, this last one, I want to find the area of a 15-gon with perimeter 180 centimeters. A 15-gon with perimeter of 180 centimeters. So same idea, I need to break it apart into those 15 triangles. It's a 15-gon, so I'm going to have 15 triangles that are going to look something like this. So whenever I take 360 divided by 15, you are going to get 24. So that top angle is going to be 24. But remember these ratios, these trig ratios, the right triangle, or the special right triangles, they only work with right triangles. So we're then going to cut that in half, which means we're talking about a 12-degree angle. Now, in order to use the trig ratios, I do need a side length. They don't give me a side length, they give me a perimeter. But it's a regular polygon, right? So if the whole perimeter is 180, how could I find one side length? 180 divided by 15, which would give me 12. But be careful, because that 12 is that whole side. I don't want the whole side, right? I'm going to cut that in half. I'm talking about a side that is 6. So they actually give me the perimeter, but I do need to find the apothem, which is going to be that adjacent side. It's going to be similar to that first one. So I have the adjacent and I have opposite. So adjacent and opposite is going to be tangent. So we are going to take tangent of 12, and tangent is OA, O over A, so opposite over adjacent, so 6 over A, can't have that A in the denominator, so multiply both sides by A, so we'd have A times the tangent of 12 equals 6, divide by the tangent of 12, and this is where I would probably keep maybe 3 decimals just to be safe. We should get about 28.228. And once you have the perimeter and the apothem, we can plug them in. So we're going to take 1/2 the apothem, which is 28.228, times the perimeter, which they gave me, is 180, When you plug that in, you should get 2,540.5 centimeters squared. Okay, so you're only going to have about 4 of those in your homework, so it's a little time consuming. The other ones in your homework are going to be much quicker, so we'll do 2 of these, but that don't take very long. Okay, number 4, so this is where you're going to use that formula that we talked about. So that formula that we talked about said to find the area of a triangle, you're going to take 1/2 and you're going to multiply 2 sides together. Whatever 2 sides you multiply together, you are going to multiply that by the sine of the included angle. So the angle in between those 2 sides. So number 4, if I have this triangle with a 56-degree angle, the 2 sides that are going to include that would be this left side, which is 6 inches, and this bottom, which is 9 inches. So for these ones, it's just plugging numbers into a formula. To find the area, you're going to take 1/2, multiply the 2 sides together, so 6 times 9, multiply that by the sine of the included angle, so sine of 56. And you should be able to just plug this all into your calculator in one big long string, and we should get about 22.4 inches squared. We'll do just one more of those. Okay, so on this one, let's say this angle down here is a 34-degree angle. This side is 10 inches, and the bottom is 16 inches. So same idea to find the area. You are going to take 1/2. You're going to multiply the 2 sides together, so 10 times 16. Multiply that by the sine of the included angle, so sine of 34. Once again, just plugging numbers into your calculator, should get about 44.7 inches squared. Okay, the last 2 problems on your homework are going to be pretty much the same thing you did on the first ones. Okay, that's like this last example that, for time's sake, we are not going to do. But just make sure you guys read the directions so you know